Hello, everyone. Thank you for joining us today at the Steelcase Sofa Shipping Container Packaging Optimization Interdisciplinary Project. My name is Emma Rodriguez, and I'm the project manager for the industrial engineers.
My name is Soraya Bellamly, and I'm the carbon footprint analyst for this project.
I'm Ryan Gorman, and I'm part of the IE team working as the carbon footprint engineer.
I'm Jared Pearson, also part of the industrial engineering team. I'm a cost analysis engineer on this project.
I'm Evan Kitchell, and I'm part of the mechanical engineering team, and I did the exterior packaging engineering.
I'm Jared Satchel. I'm part of the mechanical engineering team. I worked on the interior packaging elements.
I'm Thomas Vasquez. I'm also a mechanical engineer, and I was the lead engineer for the packaging design.
Steelcase is a furniture company that's looking for the optimal solution for their sofa product line. This includes the shipping, handling, and packaging of all the sofas.
The project's goal is to reduce the cost of international shipping by at least 20%. These costs include deliveries, packaging, and sea container. Because delivery is handled by a third party, it was replaced by labor. The objective is to focus on the sea containers because it makes up 94.2% of the costs.
The previous work that was done on this project as the last industrial engineering team made a Python tool so that we could optimize floor loading or stacking and see how many containers it would take to ship the sofas overseas. It should be noted that this was kind of made assuming that all the sofas are shipped together, but in reality, they are shipped with other furniture. But this tool still provides a good estimate that the team utilized to calculate how many containers. So here we can have 14 containers with floor loading and 9 with stacked loading. Using this output, the team was able to estimate costs and carbon emissions.
From the IE's findings, stacking the sofas would result in the greatest savings to Steelcase. During the design stage, the team realized reinforcing the packaging would increase the cost. However, the pallets cost the most money in terms of packaging, so the team decided to reduce the cost of the pallets and hope for a net zero change in packaging cost by designing a new pallet that could then offset the cost of the reinforcements. The pallet utilized the edges of the corrugated, which are the strongest element of the packaging. However, wood was necessary for rigidity when using forklifts. To implement the edges and wood together, a lattice structure was created and wrapped in a corrugated sleeve to hold it all together. The internal supports were then created in a hurdle shape to wrap around the sofa in an effort to keep the box size as small as possible.
Following our initial design and our first round of testing, the results kind of pushed us in the direction of creating an even more sustainable solution. And by what we mean of that was eliminating all the wood that was used in our initial design and replacing it with a sustainable solution. And what we used were core lock rails, as you can see here in the images. For our updated design, we used core lock rails as internal supports inside to support stacking. And then we used the core lock pallet that uses the rails as its main supports.
So for our test plan implementation, Steelcase conducts a series of testing on all of their packaging, which is just generally referred to as ship testing. And Steelcase constructed and tested our design, which we have here on the left. So this is a picture of the initial design in Steelcase's facilities, in which it underwent shock drop testing and vibration testing for the ship testing. And then on the right, we have the sofa after the ship testing. And this is just to show that there was no physical defects on the sofa after testing, which that is the only pass condition for passing testing at Steelcase.
Regarding the display of technical aspects for the industrial engineers, after conducting a sensitivity analysis, we came up with this dashboard for the calculations of the cost. They're all divided within the shipping, the packaging, and the labor, as those are the areas of interest. Two approaches were taken into consideration, one being the preferred one, which is the number of containers being used, and as well as the space utilization. A carbon emission analysis was also considered to be necessary for this project. Taking a similar approach, we went ahead and compared the current state and the future state after implementation. It was broken down into packaging and number of sea containers being used, And like that, we came up with the emission reduction that you can see here. Both files were made with the intent for Steelcase to use in the future in the case that any of these variables change.
Following the first round of testing that included simulated shipping, the first design had passed, but the team had decided to come up with the second design that was driven by Steelcase's sustainability principles and the fact that the price of lumber had gone up over the past year. This new revision of the previous design will lower CO2 emissions and decrease cost even further.
Now, based on engineering cost analysis put together by the industrial engineers, this is a very viable solution for Steelcase. Steelcase will be benefiting of $80,000 per year in savings if this packaging and loading methodology is implemented. This puts us at 35% cost reduction from its current state, which is well over the 20% goal that we had initially. Not only that, but it's also important to highlight that Steelcase has a company goal of becoming carbon negative by 2030. For this, the industrial engineering team decided to also create a carbon emissions analysis. We have concluded that with this new packaging, they'll be reducing 14 metric tons of carbon emissions per year. This is very beneficial as it is a 34% reduction from its current state.
There were two major broader impacts from this project. The first one being carbon emissions, that was just discussed, and the other one being the strain on the supply chain. By reducing the number of containers that are being sent overall, we will be able to kind of reduce that strain. If companies like Steelcase implemented this solution on many of their products, the large aggregate effect of reducing those containers could have a significant impact on freight backlog.
Since the teams understood the importance of having collective collaboration, all the great technology we have today was utilized to stay in contact and share everything we needed to. For the most part, Zoom, Microsoft Teams, Google Drive, and Discord were used to keep in contact and share documents and information between groups.
Following on that collaboration, it actually was one of our biggest challenges to effectively manage the multiple people that were involved in this project, because as a team, there are 7 members, but there are also the interested parties such as Steelcase, our advisors, and as well as any other distributors and manufacturers that we spoke with. So it was quite difficult for us to effectively manage multiple schedules at a time and being able to schedule meetings to best suit everyone involved. But this was simply overcome by emphasizing that close contact with all interested parties and ensuring that emails were sent out in a timely manner when needed.
A big motivation for the group is the opportunity to work in a real life project. Now, not all of us had the opportunity to work in a corporate company like Steelcase during a summer internship. Now, with this project, we have the opportunity to tie in what we've learned in classes and put it into practice. Now, once we graduate and go into our corporate jobs, we will have the knowledge and experience and excel better at our positions.
We met with Steelcase every other week to give updates on the project. During those meetings, the team presented new work, and Steelcase provided great feedback on whether they liked the progress or disliked it. Through this method, it kept the team on task throughout the entire project and made sure that the end goals aligned perfectly with what Steelcase wanted. The initial design through this method was completed in spring and tested, which it passed all the tests over summer, giving Steelcase the time to task the team with another update to the design that removed all the wooden elements to the design. This led the team to work very closely with Steelcase and their professional contacts in an effort to design an entirely corrugated solution. That meant every week the team was making changes and presenting them, whether via Microsoft Teams or email, to get feedback and update the design to finally get to this final updated design that we have today.
It's our job to find ways to improve upon and design products or systems to make things easier or better to live with. From the start, the team knew the potential this project had and the overall impact it can have on the company and the environment. So by choosing more eco-friendly practices like a cheaper, stronger material such as cardboard for packaging and improving the overall methodology used for placing the sofas within sea containers was stacking. And so knowing this, Steelcase is now on track for future success in reducing costs while also working towards becoming a carbon negative company by 2030.